In this lecture, we will be discussing database design. So before we get started with that, let's recap a few things that we talked about at the beginning of the semester. So when we design databases, we are going to be creating entity relationship diagrams for our databases. So an entity is a thing that we collect data about. A relationship is the association between two or more entities. And it's generally an action word that defines how the entities relate to each other. And an attribute is a single piece of information about an entity that we need to track. In our ER diagrams, or ERDs, we use certain symbols. We use generally rectangles to describe entities, and we have our relationship lines. So there's one-to-one relationships, one-to-many, many-to-many, and optional relationships. So we represent the optional ones with dotted lines. So where do we start? Well, we need to think about our scenario and list out all of the entities that we think are involved in the process. Once we have those entities down, we need to figure out what those relationships are. And if we have any many-to-many relationships, we need to break it down further to include bridge tables, because many-to-many relationships aren't allowed in relational databases. So we have a scenario. We are working at a company, and they have been having a lot of parking problems. So they've decided that they need an application to track parking in their lots. We're going to design a database for this. So the things they need to be able to track are the employee information, including their vehicles, and the driver's license number of each employee, which lots an employee may park in. So in this company, employees are only authorized to park in certain lots. And then they'll be issuing tickets for unauthorized parking. And they need to know what car was ticketed and what security officer wrote that ticket. So we're going to go into some software to create ER diagrams. I like to use a site called Lucidchart. They have free accounts. I would highly recommend this software, but you can use anything you'd like for this class. I would recommend to not use Visio, though, however, because they don't have a very good interface anymore to create ER diagrams. But if you want to, by all means, go ahead. It's just not very user-friendly. So in Lucidchart, I've created a new diagram, and I'm going to look for an entity. And it comes up with a number of options here. So we've got the option for just fields. We've got keys and fields, fields and types, keys, fields, and types. At this point, I'm just going to use the keys and the field option. So I'm going to drag this onto my canvas here. And I know I'm going to need a couple of them, so let's just drag some on here. And if I go back to my scenario, so a couple of things we need to track. We need to know about employees. So I'm going to name my first entity employee. And we need to know about vehicles. So I'm going to track vehicles. I'm going to include an entity for that. And we need to know about tickets. So we're going to start there. So for an employee, we should know their employee ID. We need their name. We should probably break that into first and last name. And we need to know the driver's license number. So here I'm going to increase this to add another field. Okay. And then let's add another one for what lots they may park in. Authorized lots. So if we go to our vehicle, we should have something to identify a row in this table. So I'm going to give it a vehicle ID, or we could go by the license plate. Now, license plate may not be the best choice because you can transfer license plates between vehicles. You could make that decision either way here. I prefer not to use that as the primary key, as the identifier for my table, because it could change. So I'm going to use a vehicle ID that we would generate. But we also want to track the license plate. And we should probably know what state that's for. Okay. And probably the make, model, the year, and the color. And then we need to know about tickets. So we should have a ticket number. We need the officer who wrote the ticket. We should probably have a date. Sorry guys, I hit the wrong thing there. Ticket date, date time, and I want to know what vehicle I ticketed, right? So let's give that the license plate. And the license plate state. Okay, so we've got the basic stuff down there. Let's add our relationships here. So when I think of employee and vehicles, I know an employee could have multiple vehicles. Is it possible that a vehicle could be owned by multiple employees? That multiple employees could drive the same vehicle? Yes, if we had a husband and wife who worked there, if we had siblings or friends or roommates, that could happen. So I can change the end of my line here. And then what is it that we actually ticket? Do we ticket a person? Do we ticket a car? I'm going to say we ticket a car. So I'm going to drag this around to here. So a vehicle could have multiple tickets. So I need to change my feet around here. And a ticket belongs to only one vehicle. So I could do that, or I could have just hit this switch line endings button, which makes it very useful. So if we go back to this, we notice we already have a problem. If our relationships are many to many, we have to break it down to a bridge table. Okay, so this is a problem. So what we want to do is add another entity, and we're going to call this one employee vehicles. And what we're going to track here is the employee ID and the vehicle ID. And that's all that this table is going to contain. So now this line actually goes away. I'm going to move this over. And I'm going to plop this table in the middle. So an employee can have many vehicles. A single vehicle here belongs to one employee. A vehicle, again, can belong to many employees. But an employee here has just one. So for each record here, since this is our bridge table, the manys go on both sides here on the bridge. Okay. So we are good here. Next thing, we want to identify the attributes. We did that. We're good. Are they all single valued? This means, do we only store one thing in them? If not, it needs to become its own entity. So let's take a look at this again. There is something here that is not single valued. So when I look at my employees, this authorized lots field could have multiple parking lots that an employee may be authorized to park in. So that could contain multiple values, which means it should really be its own entity. So what I'm going to do is add another entity. So it would be employee lots or employee authorized lots. I could just call it authorized lots too. I think that's what I'm going to call it. Let's make it a little bit shorter. So this is going to be the employee ID and the lot. And now I'm going to take this authorized lot field out and remove it. So now my relationship here is one employee can have multiple lots they're authorized to park in. So I'm going to flip this around. And one record here belongs to only one employee. Okay. And then we want to make sure that each attribute is really part of the entity. So when we set this up, I think we did a pretty good job of that. Just going to move these things around a little bit, make them look a little nicer. Likes to do some funky things with the lines here. Alright, bring this down here. Okay. So now we want to identify the primary keys for each table. So the primary key is the column or columns that make a single row in the table unique. If we have multiple columns for the primary key, we call that a composite primary key. So some things to keep in mind with our primary keys is that any column in a primary key can never be null. So if a table has a composite primary key, no part of that key can be null. No column that is part of a primary key can be null. So let's determine what our primary keys are here. So I'm going to manage this. In this employee table, our employee ID should be the primary key. So I'm going to label this as the PK, primary key. This is not, and this is not. Now, driver's license could be used for that. However, when people get married or change their names for some reason, divorced, just randomly decide to change their names, their driver's license number tends to change. So we don't want we don't want our primary key to be a field that can change. The employee ID for a person should never change. So we're going to use the employee ID field as our primary key for employee. So let's go to employee vehicle. So for a single record to be unique in this table, both of these fields have to be our primary key. Because an employee can have multiple vehicles, which means the employee ID would show up more than once. And a vehicle can be driven by more than one person, so that could show up more than once. So the unique combination in these two fields is what's going to make a record unique. Okay, so if we do our vehicle, the vehicle ID is what is going to be our primary key. Because again, license plates can change between cars, and we don't really need to track a VIN number for this sort of an application. That would be a little bit overkill. So we go to a ticket. The ticket number is going to be our primary key. And authorized lots. Here, our employee can have multiple lots, and a lot could have multiple employees. So both of these need to be part of our primary key. So that's step seven. So move on. We also need to do our foreign keys. So a foreign key is the reference to another table's primary key. So in our Northwind Traders database, in the customers table, customer ID is a primary key. But when we see it in the orders table, that's the foreign key. So the customer ID has to exist in the customers table before we can use it in the orders table. So if we look at these, there's no other reference in this table, so we have no foreign keys in employee. If we look at authorized lots, we need the employee ID to exist in the employee table before we can give them authorized lots. So this is also going to be a foreign key, and I'm going to use FK to identify that. If we look at employee vehicles, we need the employee to exist in employees, and we need the vehicle to exist in vehicles. So both of these are foreign keys as well. And I can make this a little bigger. If I go to vehicles, I don't have any foreign keys here. And if I look at tickets, I'm not tracking the vehicle ID here. And there's a reason for that. So if the vehicle is owned by an employee, that means I'm going to track it, and then I can give it a ticket. I could also assign tickets to license plates to vehicles that aren't owned by employees, in which case I may or may not want to enter the vehicle in the system. If it doesn't belong to an employee, I might just want to give it a ticket instead of having to track it. So we could include the vehicle ID here, but we'd want to make it optional. So I'm going to add vehicle ID. That's going to be my foreign key. And to denote that this is an optional relationship, I'm going to change this to a dotted line. So I don't actually have to have vehicle ID to issue a ticket, but I could have one, in which case the vehicle would be related to the ticket. So we got our foreign keys in there. So let's talk about a few other things here and see if we need to make any changes. So do's and don'ts of database design. So if you ever have a table where you see yourself adding item 1, item 2, item 3, this is a really bad idea. So if we had decided to put in the employees table vehicle 1 license plate, vehicle 1 make, vehicle 1 model, vehicle 1 year, vehicle 2 license plate, vehicle 2 make, vehicle 2 model, that's a bad thing. That's a sign that you need to move the information to a new entity. So kind of like we already set up here, vehicle information didn't belong on the employee. It belonged on its own thing. It's its own entity. Other do's and don'ts. We don't want to have a single code table. So if we had something like an employee type, so let's add that on here. So we want to know if they are an employee, a contractor, a temporary employee. We could track that here. And if we have lookups for make and model, so if we have a table that tells us the makes and the models of cars so we don't have to type them in every time, we don't want to store that all in one table. We'd want to have separate tables for this. So I'm going to have my employee type table. So employee type ID and description. This is going to be my primary key. And this becomes employee type ID. And this is a foreign key to this table. Okay. And if I want to make a model lookup table, vehicle makes, or I could just do models. Because a model belongs to a certain make of vehicle. So we have make model. This is my primary key. And then I can say model ID here. And this is actually a foreign key. Okay, so it's getting a little more complicated with all these extra type tables, but these are a good thing to have. The benefit of having them comes to how our design impacts applications. So if we have fields that are text fields, so before we had make and model in vehicle, we could type them in. That leads to a couple different problems. It leads to inconsistencies. Somebody misspells something. And even if we somehow limit this in the application so they can't misspell it, if we ever wanted to report on all the different makes and models, we wouldn't be able to do that from the database unless there was a record for each of them. So if we have that type table, we have every option available to us. We can always report on it. It's also more consistent, and it saves space because all we're storing is an ID number rather than the text over and over and over again. So we have that. And another place in our database where we have that going on, this free form text, is the lot. So we don't want that. We want to add a parking lot table. So this is our lot ID. It's our primary key. And we have a description. So this becomes our lot ID. And this also becomes a foreign key. And this is actually a bridge table now. So it's a bridge between the employee and the parking lot. And then if we go over here to our tickets, we have an officer. Well, rather than typing in the name of the officer every time, we should probably have a table that tracks our officers. So a security officer is an employee, so I'm going to use their employee ID. It's going to be the primary key. And we're going to have a badge number. And we could track other information, but that's all I'm going to put in there for now. Put this here. So this is actually going to be here. This is actually going to be a one-to-one relationship. So each security officer is one employee. One employee can only be one security officer. However, not every employee is a security officer. So we're going to track the badge number here, and anything else that relates to them being a security officer would be tracked in this table rather than in the employee table. So this table is everything that is common to every employee, and this table is fields that would only relate to security officers. So I'm going to have my officer ID here. That's a foreign key. And this is going to go here. So one officer can write many tickets. A ticket is written by only one officer. So my ER diagram has gotten a bit bigger than our initial 3 to 4 entities we started with. So other things we can do here in Lucidchart to make our diagrams look better. So we can alternate the row colors, shade our headers. This just tends to make our ear diagrams look a little bit more professional. So I usually do this. It also makes them easier to read. So when I am done, I would want to give this a name. So I'm going to call this Parking Application ERD, for ER diagram. And then I can download my diagram as a PDF. So that's what we're generally going to want. You could also do Visio. Again, I don't recommend using Visio. Personally, I recommend using this application, but any software application that allows you to create an ER diagram will be fine for this class. So that is database design in a nutshell. There's a lot that goes into it, and our concepts that we talked about in the normalization video also help us a lot with this. But database design is a very iterative process. You go through it over and over. Like you saw, we started with just a couple tables, and we've expanded to 1, 2, 3, 4, 5, 6, 7, 8, 9. So we started with employee, vehicle, a ticket, and tripled the number of tables. When is it done? It's done when it's easy to use and it meets the requirements. So in this, can we track an employee? Yes. Can we track their vehicle? Yes. Their driver's license? Yes. Which lot they can park in? Yes. Tickets? Yes. What security officer wrote the ticket? Yes. We've met the requirements. It's easy to use. It's easy to report off of. We have primary keys. We have foreign keys. We're good. Creating databases like this will take you a bit of practice. It doesn't come naturally to everyone. So if you struggle with this, don't worry about it. It's just going to take some practice. So when we get to class, we will practice more of this. That's it for this video, and I will see you in class.